Hi, Year 11. We're studying the next topic now, and it's chapter 17 from the Cambridge book, and it is further trigonometry. 17a is our first part, and it's basically looking at the topic what we did before in chapter 5, and we're restricting the domain. So, recalling from inverse functions. Any inverse relation can be found by reflecting the original graph in a line y equals x. The inverse relation is an inverse function if the horizontal line cuts the original graph only once. The domain and range in the original relation becomes the range and the domain respectively in the inverse relation. We basically flip them around from each other. To find the equation of the inverse relation, swap the x and y and then solve to find a new y. We use f of x for the original function and f to the minus 1 of x. Just be careful where you put that negative 1, okay, so that you don't get it confused with the reciprocal function. And we can restrict the domain of the original function so that we can find an inverse function. So that relates back to that second point. If the inverse relation is an inverse function, if the horizontal line cuts the original graph only once. If it cuts it more, we often need to go back and restrict that domain if we want to make it a function. So let's work through these. You probably, if you've done the work from last time and done that well, will be able to work through this. So we want to find the inverse of y is equal to the square root of x minus 5. So to do that, we need to swap the x for the y and the y for the x. So we're just going to write that as x is equal to the square root of y minus 5. Now we need to solve that for y. So let's square both sides, and we end up with x squared is equal to y minus 5. So we get x squared plus 5 is equal to y. So where our original, we're going to call f of x, what we now have is f inverse of x is equal to x squared plus 5. Let's have a look at the second one. So we're going to find the inverse of y is equal to 3x to the power of 4 plus 2. So first of all, again, like before, we want to swap our x's and our y's around. So x is equal to 3y to the power of 4 plus 2. We want to solve for y. So we're going to have x minus 2 is equal to 3y to the power of 4. X minus 2 divided by 3 is equal to y to the power of 4. Now, we need to take the fourth root of both sides. So the fourth root of x minus 2 over 3 is equal to y. This was our original function, f of x. Now we have f inverse of x, and it is equal to the fourth root of x minus 2 over 3. And that was basically the work that we did in the last topic. So make sure that you're confident with those. If not, go back, work that last topic, and make sure that you're feeling confident before we move on to the next question. Okay, let's look at that next example. And it says, write down the inverse relations for the function f of x is equal to 1 minus x over 1 plus x. So we're going to swap the x and the y, and it's saying the inverse relation because we don't know if it's going to have an inverse function because we may need to restrict the domain. Once we've done that, if the inverse is a function, we're going to find an expression for f inverse of f of x, and we know that equals to x if you think of the last topic, and f of f inverse of x, and that will also be equal to x. Okay, so let's just start with the first part. F of x is 1 minus x over 1 plus x. Now that f of x is also our y. So I'm going to start by writing that y is equal to 1 minus x over 1 plus x. Now in order to find our inverse, what we want to do, and decide if it's an inverse relation or a function, is swap our x's and our y's. So I'm going to then write that to find our inverse, x is going to be equal to 1 minus y over 1 plus y. Now this is what we would call our inverse relation. If we can solve that and get a y equals, then we will have a function. So let's see if we can solve that and get y equals. Okay, just using some simple algebra, I'm going to multiply both sides by 1 plus y. So I'm going to get x lots of 1 plus y, and it'll cancel out on the right-hand side to leave me just with 1 minus y. Let's expand the left-hand side, so I get x plus xy is equal to 1 minus y. Now, the aim is to try and get y equals, so we need to get our y's together. So let's pull that minus y to the other side. So we're going to get x plus xy is equal, plus y is equal to 1. I now might get that x here to the other side. So we'll move that x over. So I get xy plus y is equal to 1 minus x. Little line in there. And I can factor the y's out here. So I'm going to get y and x plus 1 equals 1 minus x. If I now divide by that 1 plus x, or x plus 1, whichever way you've got it in yours, I'm going to have 1 minus x, and I might just write it as 1 plus x, just because it looks similar to that top line. So now we have our relation in terms of y equals, and that's an inverse. So we can write that f of inverse x is equal to 1 minus x on 1 plus x, and that's our inverse function. So that's basically saying there's one solution for y, and that's why it's a function. Now the second part of the question said if the inverse is a function, so it is, we want to find an expression for the inverse of f of x and f of f inverse of x. And they, if you remember from our last topic, will always be equal to x, but we can show that. So I'm going to start with the blue part that I've highlighted first, and I'll do that writing in blue. So we're going to start with the left-hand side. We want to find f inverse of f of x. That's our left-hand side. Let's show, by working, that we end up with x. I've just zoomed out there so we can see what we need to do. So we basically need to find f inverse of x, which is down here. And that's our 1 minus x, 1 plus x. And what we want to do is sub in where there was an x, our f of x. And our f of x is that original function that we were given at the start. So what I need to do is sub in where there was an x, my f of x. So we're going to have a 1 minus f of x. Basically, that's what we're going to have happen. 1 plus f of x. So I'm changing that x to an f of x. So let's pop that in. So 1 minus, and my f of x is 1 minus x, 1 plus x, all over 1 plus 1 minus x, 1 plus x. So now you just need to do some algebraic equations here to neaten that up on the top line and the bottom line. So let's get our top line all over 1 plus x, 1 plus x. So I need to have a 1 plus x up there, and I've already got a 1 minus x there. We just need to make sure that when we join them together, that minus carries through. And on the bottom line, we're going to have a 1 plus x and a 1 plus x. And we have a plus on the bottom there. So on this side, I'm going to have a 1 plus x and a 1 minus x. Okay, now let's neaten them all up. On the top, everything is over 1 plus x. And I'm going to have my 1 plus x on the left here. But that minus is going to carry through to be minus 1 plus x. Minus 1 plus x. My bottom line, I have a 1 plus x. And my top line, I've still got that 1 plus x on the left. Oops. And I'm going to have added to that my 1 and my minus x. Plus 1 minus x. Let's neaten it up. On the top line, my 1's will cancel out, and I'll end up with a 2x over 1 plus x. And on the bottom, as my denominator, I've got my 1 plus x on the bottom. And on the top there, I'm going to have, oops, what's happening there? My x's will cancel out. Sorry guys, my computer's doing strange things. I'm going to have a 2. And my x's are going to cancel out. And a little p that's arrived there, we don't want that. So that's what I've got. Now, some of you can straight away see that's going to be x. If not, let's see what we've got. We've got 2x over 1 plus x on the top. And what we're going to do is multiply that by the reciprocal of the bottom line. Because remember, when we have a fraction bar here, it's divided by. So we're going to basically flip the bottom and times by it. So we're going to be multiplying by 1 plus x over 2. These will cancel, the 2's will cancel, and we end up with x, which was what we wanted on the right-hand side. So a little bit of algebra, actually really good practice for your advanced skills as well. So we've proved the blue part. Let's now prove the green part. Similarly, I'll do that in green so you can see what we've got. Oops, sorry guys. Okay, now, same way, we're just going to be starting off with our function instead of our inverse. So the left-hand side has got f of, and we're going to sub in our inverse of x. So what's our function? Our original function up the top was 1 minus x, 1 plus x. So we're going to have 1 minus, and we're going to sub in where our x was, the inverse of x. 1 plus the inverse of x. That's what we're doing. If that helps you to pop that in straight off, do that. So let's pop those in there. So 1 minus our inverse of x, you look back down here, it was exactly the same as our function anyway. 1 minus x, 1 plus x. So we're going to have 1 minus x, 1 plus x on the top, all over 1 plus 1 minus x, 1 plus x. And what you can see, it is identical to what we had previously. To the last question. So I'm not going to work this one out, but you can go and practice it, okay? Therefore, it equals x, which equals the right-hand side. Okay. So none of that is new, okay? Let's have a look at the next part. Okay, so this part's a little bit new because we need to restrict the domain. So it says, by restricting the domain of the function y equals x squared plus 4x, find the inverse function defined over that domain. So what we should do in these questions is let's draw a graph first. So let's sketch y equals x squared plus 4x. And we can factorise out the x, and we get x plus 4. So we know we're going to have zeros at 0 and minus 4. So let's quickly sketch that. Now, there's our parabola, cutting at 0 and minus 4. Now, if we were to do a horizontal line test, we can see that there isn't a unique value for each y value. So in that case, the inverse is not going to be a function. Okay, so the reason why we needed to draw it was to get an idea of what this looked like, but we also want to have a look at the turning points in here, because the turning point is going to be the point about which we're going to look at the restriction. Because when we have our turning point here, which is going to be, what have we got? It's going to be minus 2. It's going to be minus 2. Sorry, not minus 2. It is, but that's going to be minus 4 there. Okay. So the turning point is going to be the point about which we're going to restrict our domain. Because anything above that turning point is going to fail that horizontal line test. If I was to restrict my domain and only have it for part of that parabola, say for example, x is going to be less than minus 2, so I'm only looking at the left-hand side of my parabola. If I did the horizontal line test, then it's not going to fail. Likewise, if I use the right-hand side as well. So we need to either restrict and make our domain for values less than or equal to minus 2 or greater than or equal to minus 2. And there's no real hard set rules on what to do with those. We can generally pick either. So we need to pick a domain. I usually pick a domain that includes 0, just to help you out. And you've got a part that you know where it is and it sits nice and easily on the graph. Okay, that includes that 0. So what I'm going to do then is I'm going to pick the part of the graph and I'll highlight it for us. This part of my graph. So that's what my restriction is going to involve. So what I'm going to look at is I'm going to look at values of x that are greater than or equal to minus 2. And if I was to do the horizontal line test now on my highlighted part of the graph, then it's going to pass the horizontal line test. And we'll write that down. So x greater than or equal to 2 as a restricted domain we'll say this part of the graph passes the horizontal line test. Oops, sorry, I'm doing funny things with my keyboard. Okay, so what we could actually do is we could draw, if we wanted, what the inverse graph would look like. If that is something that you would like to do, I think it's a good thing to get into your head what that would look like. So basically what that would mean is our function and our inverse reflect around the line y equals x. So if I just dot in y equals x there, and I can see I've got a -2 and a 2, so that looks right. Our inverse would have looked like, let's have a look. This would have gone through -4 and 0, okay, and it would turn at -4 and -2 down here. So the inverse, and mine's not to scale, but mine would look kind of like that. So on that inverse graph, I just made a mistake and just had to fix it up, because you just got to think what you're doing. You're not sliding this graph down, you're actually reflecting it about the line y equals x. So if you were to do that and reflect it, the part of the inverse graph we want is my yellow part up here. Just be really careful that you're getting the right part of that graph for the inverse. So now we can use that restricted domain and actually find what that inverse is. So the yellow part of that graph is going to be for values of y that are going to be greater than or equal to -2. So remember when we were swapping the domain and the range for our inverse? So we're basically getting our value that we had up here for our restricted domain of the function, making that a y, that's our restricted domain of our inverse. So we can now work that out. We need to find a solution for this, and the only way to do that is to complete the square. So let's do that. Let's write complete the square underneath. Okay, so x is going to be equal to, so we're going to have y squared plus 4y. We halve the 4 and we end up with 2. We square the 2 and we get 4. So we're adding 4 to that side and we're adding 4 to that side. So what we end up with then is x plus 4, and in completing the square, what we've ended up with, 4 divided by 2 is 2, so that's what we've ended up with. Okay. If you're not sure about completing the square, go back and practice, pause the video, and make sure that you're comfortable with that. Take the square root of both sides. So we're going to have plus or minus the square root of x plus 4 is going to be equal to y plus 2. Plus or minus the square root of x plus 4 minus 2 is equal to y. Okay, so in our restricted domain, we only want the positive part of the graph because I've only picked the positive part of my original function and I'm only using the positive part of my inverse. So what I actually want to have is that y is going to be equal to just the positive version of x plus 4 minus 2. And that is my inverse of x is equal to that. But we haven't answered the question yet, because what we want to do is make sure we've got the right domain and range for that inverse function. I'll just name that up there a little bit. Okay. Okay, so I've just written to the side here, and I know this is, I'm going really slow through here. We want to find the domain and the range of those inverse functions. Now we classified the range of the inverse as y is going to be greater than or equal to -2. Because that was basically the same as the range, sorry, the domain of the original function. So we popped that as a y. But you could see in there that that point was our turning point on our inverse, and that related back to y being greater than -2. So we can figure out the domain of the inverse by just looking at, well, what's the other point here? It's -4. So we're going to have x values that are going to be greater than or equal to -4. But that is not the only way we could work that out, and I'll show you that as well. So if we didn't have a graph already done to work that out, and we know that our inverse range is y is greater than or equal to -2, then we can just get our function of our inverse, which is the square root of x plus 4 minus 2, which we worked out over here, and pop that, which is our y over here, and that's going to be greater than or equal to -2, and we could just solve for that. So if we were then to say, okay, we've got square root of x plus 4, add 2 to both sides, that's going to be greater than or equal to 0. We square both sides, x plus 4 is going to be greater than or equal to 0. Take 4 from both sides, x is going to be greater than or equal to minus 4, which was the same as we got our range from the graph.